All right, so this is a chapter on integration by substitution. And integration by substitution is a method of integration that helps us determine a result of a particular function if it's somewhat more complicated, but if it has a particular form that we can associate to it. So I'm going to start out with going back and reviewing the chain rule for differentiation. So the chain rule for differentiation was the derivative of a compound function where you have f of g of x, and the result out of it was f prime of the function g of x times g prime of x. Now this form for the chain rule can actually be drawn to this integration by substitution concept by taking the integral of both sides of this relation that's been drawn out. And so if you do the integral of e prime of I of x times I prime of x dx, then that's going to have the result of e of I of x plus c as the end of, or as the antiderivative of that integral. Now, the whole reason why this works out is because we can basically do this integration on both sides of the chain rule and see that we get a result out. But it's also kind of nice to see sort of how calculus can be used to build upon previous concepts that we've had and get something out of it like this. So let's take a look more closely at a couple of forms that you can see. So we have the integral of f of x to the nth power times f prime of x dx. That's going to give us f of x to the n plus 1 power over n plus 1. And then we're going to have an constant of integration plus c at the end there. This works for all n that are not equal to -1, mainly because we'll be looking at the natural log case at the end of this page, which concerns that specific instance of n equals -1 for this formula. But let's look at the exponential general formula using U substitution or integration by substitution. And that's the integral of e to the f of x times f prime of x dx. And the result out of that will be e to the f of x plus c. This is very similar to the result that we got by looking at the chain rule initially for the exponential function with a function instead of x. And if you look at it, it's actually the reverse result. If you forget about the constant of integration for a second, and that's almost exactly mirroring how you have the result from the chain rule, just going in the opposite direction. It's something that you can hold to all of these general formulas, but it's something that's very evident specifically with the exponential case. If we're looking at the last one, which I mentioned, which was the natural log general formula, then we can say that if you have something of the form where you're integrating over the function or a function, which is 1 over f of x times f prime of x dx, then the result out of that will be ln of the absolute value of f of x plus c. So the whole reason why this is mainly just because if you do that differentiation or the chain rule property on this, you'll see that you get out the same thing. But it's also kind of just a property of the log function that you'll kind of see. And so when you're looking at this, that's what you should kind of be thinking about in terms of the f prime of x over f of x situation, is that, oh, that's kind of a natural log kind of property that we're thinking of. And so that's what you got there for those general formulas. Let's look at differentials very briefly, because we've been talking about doing U substitution. Well, U substitution or integration by substitution will use differentials and a change of variables, which relates to how differentials are related to each other. And so if we have our y equals f of x, then our dy, the differential for the change in y, is related to the differential for x, or dx, by dy equals f prime of x times dx. And so this can be used to change the differential of an integral into another differential or into a new differential. And so if you have a function that relates two variables, a y and an x, a u and a v, whatever you want, then you can use this formula or this method to change from one of those variables into another one. And that other form might be a little bit easier to integrate over. It's also the part of the method to how you might be able to get some of these more general formulas for our integration that we were just doing or just talking about, which relates back to the idea of the chain rule integration that we were doing. And so if you have u equals f of x and your du equals f prime of x dx, then you can do u substitution, or integration by substitution as they call it, for each of these cases that we looked at initially. So for the integral of f of x to the nth power times f prime of x dx, then we can say that we have the integral of u to the n du by saying that we are substituting all of the f of x's for u's and then substituting the f prime of x dx for du. And the result out of that integral would be just the power rule for u. And that would be u to the n plus 1 over n plus 1 plus the constant of integration c. The result, if we plug the u back in for that being u equals f of x, then we'll get f of x to the n plus first power over n plus 1 plus the constant of integration c. And that'll be what we have for that case there. And that is what we had originally from the other general formula, how it was rewritten out. And it follows very closely with what we've talked about regarding the chain rule and the antiderivative regarding the chain rule. And so everything here kind of comes together and works out fine and works out well, which is what you like to see in a logical system for mathematics, is that everything kind of agrees no matter which path you take. We can also talk about the exponential formula in general using substitution. So we have the integral of e to the f of x, f prime of x dx, and we use u substitution or substitution as a method of integration. Then we'll get the integral of e to the u du is equal to e to the u plus c, which then we can look back at the what we set u equal to, which is f of x, and we can substitute that back in to get e to the f of x plus c. Again, it works out the same as what we had before, and we're happy with that, and we can move on to the next one. And so the integral of 1 over f of x times f prime of x dx, if we do u substitution, would be the integral of 1 over u du, and the integral of 1 over u du is equal to the natural log of the absolute value of u plus the constant integration c, and that'll give us the solution of natural log of the absolute value of f of x plus the constant integration c as our result. And again, for the last time, we are seeing the same thing that we saw before from the general formula initially when we were looking at it. And so we're happy to have all of that be consistent. So this has been a chapter kind of talking about how to do substitution and what it's useful for and some of the formulas you can get out of it. And so hopefully this was good to see and can be used later on for some of the problems that you'll be working on. So, all right. I'll see you in a little bit for the next section.